Hello everybody, this is Professor Anup Gare from Tulsiramji Gaikwad Patil College of Engineering and Technology from the Department of Information Technology. And in our first video, we have seen the basics of operating system, and that we have seen the definition of an operating system and the various roles of an operating system. In this second video, we are going to discuss types of operating system. Rather, we are going to discuss types of system and operating systems required for these systems. Okay. Now, as I already told you in first video, we have seen that mainframe computers, then multi-programming operating system, time sharing system. Now let us talk about desktop system. Desktop system, in other words, are personal computers. So computer system dedicated to a single user, in which IO devices are keyboard, mouse, display screen, even a small printer. The convenient system is basically designed for a single user, and the main aim for this single user system is a convenience, that is ease of use and the quick responsiveness, because single user cannot wait, rather he or she is not willing to wait much for a response from a system, and can adopt the technology developed for even a large operating system. Often individual user have a limited use of computer and do not require advanced or a high-end CPU utilization for a protection feature. Your single user system can run many operating systems, many versions of operating system, which includes right from Windows family to your Mac, or even Unix or Linux or even Solaris or whatnot. So variety of operating systems are available, and all these systems are easy to use. Okay, the next system is a parallel system. Parallel system, a multiprocessor system with more than, of course, one CPU in a close communication. Whenever I'm saying close communication, means they are sharing things with each other via shared memory or via buses. These systems are the tightly coupled system. Processors share a memory and a clock. A very important thing, that it shares a clock, because normally system may share a memory, but sharing a clock is not a normal part, or a common thing. Communication usually takes place through or with the help of shared memory, as I already said. And with the use of parallel system, you may find out that the overall efficiency, the overall throughput of your system has been increased. What is meant by throughput? The simple example if is, let us say, if we have 10 system in a closed loop, and out of the 10 system, one system get failed, then whatever the task the 10 system is performing, that task has been divided to all remaining 9 systems. So obviously, though our one system got failed, but the entire task is not hanged up or held up. System is performing its own task. That is basically the reliability. Now, let me elaborate the concept of throughput. Throughput means per second output, or per unit output is large. Okay, basically for parallel system, because as we know that number of systems are performing parallelly, number of systems are doing their task parallelly, obviously the output, the result will be quite better than the normal system. It is economical in nature, as we know that it shares the memory. It performs their responsibilities and the task in a very fast manner. So it is, the systems are economical in nature. It increases the reliability. As I said, the task of 10 system has been divided to the remaining 9 systems, so it is reliable in nature. Graceful degradation, the best example is your tandem system and a fails of systems. Then symmetric multiprocessing, SMP. Each processor run an identical copy of operating system. Many processes can run at once without performance deterioration. Deterioration will be avoided over here. And most of the modern operating system, whatever which are available, they are supporting this symmetric multiprocessing. Then asymmetric processing, each processor is assigned a specific task. Master processor schedules and allocate a work to all the remaining or slave processors, more common in extremely large systems where client and server architecture has been followed. Then this is the architecture of symmetric multiprocessing. Memory has been shared. That's why we say that it is economical in nature. Multiple CPUs are attached with the buses, and there is no master or a slave computer. Okay. Then the next case is a distributed system. Obviously, whenever we are talking about distributed system, network is essentially there. Without network, distributed system cannot be there. It distribute the computation amongst the several physical processors, because whenever we are talking about a distributed system, multiple systems, multiple processors are there, and in these distributed system they may be a tightly coupled or loosely coupled. So loosely coupled system, each processor has its own local memory, and processor communicate with one one other through a various communication lines, such as high speed buses or even telephone lines are used for communication. Okay. Advantages of this distributed system is resource sharing, and whenever we are talking about resource sharing, obviously it is economical in nature, and when multiple systems are attached, obviously computation has been speed up, because distributed system can share the load also. At the same time, it offers us the reliability, because if any of the system fails, other system can share its load, and communication will be very effective whenever we are having a distributed system. uh, as I said, distributed system requires a networking infrastructure. Without network, you cannot expect the distributed system. Local area networks or even a wide area network can be worked over there. Maybe either a client server or even peer-to-peer systems can be there within this distributed system. General architecture for client server architecture, you may see here a server is there and multiple clients are attached over here with the help of network. Okay. Then cluster is basically a group. Clustering allows two or more systems to share a storage. It Whenever two or more systems are there and they are sharing a resources, it provides higher reliability as compared to the other. Clustering can be either a symmetric or asymmetric or symmetric. So in case of asymmetric clustering, one server runs the application whereas others are standby, and in case of symmetric clustering, all and host are running the applications. Okay. Then a very important and interesting kind of operating system, that is real-time systems. This real-time operating system often use a control device in a dedicated application, such as controlling scientific experiments or even medical imaging system or industrial control system and some of the display system. These real-time operating systems are very important, because in this real-time operating system there is no second thought, there is no concept of multi-programming or time sharing, nothing. All the system, all the focus is on single task only, and time constraint is absolutely fixed. You cannot expect a delay in this particular kind of system. Real time system may be either a soft or a hard real time system. Hard real time system, secondary storage is absolutely limited, or you can say that it's absent. No secondary storage would be there, and data is stored only in a short term memory, or you may say that read only memory. And conflicts with time sharing system is not at all supported by this real time operating system, like a general purpose operating system. Whereas in case of soft real time operating system, it is limited utility in industrial control like robotics. It is used in applications like multimedia or virtual reality. It requires, of course, it requires advanced features of an operating system. But whenever we talked about hard real time operating system, it has no compromise with the time. Absolute 100% matching with the time is required. In case of soft real time, some minute compromise in time can be there. Finally, at the end, we will have the handheld systems. The personal digital assistants or even modern cellular phones which we are using nowadays are basically handheld system. The operating systems are basically designed for limited battery, limited memory. But I can be very sure that you will have a question nowadays. Even your mobile phone, your cell phones having a huge amount of memory, even 64 GB or even 128 GB. So nowadays they're having a very huge memory, but the quick responses are the essential features of these handheld systems nowadays. Earlier days, slow processor with the limited capabilities were used. Screen display was comparatively small as compared to the laptop or a computer. Nowadays, enough screen displays are available, but still their main focus is towards responsiveness and the battery life. Consumption of battery life should be limited. So this covers all types of operating systems which are essential for the uh, basic understanding, and I hope uh, you have well understood all these systems thoroughly. Thank you all.